Okay guys, so in this lecture we'll be discussing some more examples, a couple of more reactions on again the passing on H minus or LiAlH4 in some compounds, and then we'll be coming on to industrial preparation of phenol. Okay, so let's get started. So we have something like this is an important example. So we have NO2 group here, and what happens in LiAlH4 presence will reduce NH2 and OH would be here. And what happens when we pass it with NaBH4? NaBH4 only attacks on aldehyde, ketone, acid chloride and halide. Okay, so it will not reduce NO2 group, it will only reduce ketone group, and NO2 would be intact. Okay, let's see another example. We have a nitrile, okay, and we pass some reducing agent LAH, so we'll be getting something like CH2NH2, obviously RCH2NH2. And if we pass isonitrile again in LAH, so we'll be getting RNH2CH2. so these two are functional isomers. Okay, so now let's move on to next topic, which is industrial preparation of phenol. Okay, so we have something like this, which is cumene. Okay, and first we are reacting it with oxygen in presence of H nu, and second we are reacting it in acidic medium and providing some hydrolysis of the same. So we'll get something like phenol, and what else we'll be getting, which is this is actually very inexpensive. Okay, from the inexpensive compound we get expensive compound, and this also has a real life utility, this acetone, which can be marketed as nail polish remover. Okay, so from one inexpensive compound we got two highly useful daily life compounds. This has many practical applications, maybe not in daily life but in other chemical industries. Okay, so let us look at the mechanism of this reaction. Okay, so first we have something like, we use any dummy compound or a peroxide to actually trigger this reaction step. So we get 2 moles of RO dot. This has nowhere to do with what the future steps are, but it is just for triggering the reaction. You will understand what the triggering of the reaction means in this step. So we have the cumene, something like this, CH3 is here, and CH is here, and again CH3 is here. So what this RO dot will do is, it will take away the H dot, and it will create something like a free radical, a cumene free radical. Okay, so what next would happen is, we also have passed oxygen in H nu, right? So this dot would be attacked rather by oxygen, and we'll get something like this bond would be broken up, and we'll get something like CH3 and CH3 here, and oxygen dot here, O dot here. Okay, again what will happen is, again this O dot will actually attack on this another cumene compound, and we'll get something like actually attack on this H dot, and it will have a OH here. So we'll be having something like OH, and again this will be converted into a cumene free radical. And pH. So what next would happen is this OH would be leaving, okay, and as a result this pH group would be migrating to this oxygen atom, and we'll get something like CH3, positive charge here, oxygen, and pH here, OH minus released, okay, and we'll get something like another cumene free radical is also there in this reaction, which will further again be attacked by oxygen molecule to again form the intermediate. So what will happen in this case is again water molecule will actually attack on this case, on this, and we'll get something like OH and OPH. Then what will happen is again this carbon atom, oxygen atom will donate its lone pair here, and O minus would be leaving, and we'll be getting something like a ketone group or acetone rather, and then pH O minus again on reaction with water molecule will take up H from the water, and we'll get something like this. Okay, or rather we are of phenoxide I will take H plus from the more acidic medium which we are providing as a H3O plus. Okay, we'll take the H plus from there. Okay, so okay, let me write it down clearly. H3O here only, so it will take the water molecule or the H plus from the acidic medium only. Okay, so with this we come to an end of this lecture. So in the next lecture we'll be seeing some oxidation reactions. So till then, good luck and goodbye.